If we're trying to figure out the percent composition of a molecule or any sort of substance, all we're doing this is comparing the mass. The mass is specifically that element to the mass of the entire molecule. So for our first number, our first molecule is CH4. We could compare that, that's 1 atom of carbon to 4 atoms of hydrogen. We can compare it that way. But we could also compare it by mass. So of the total mass of CH4, what percentage is carbon and what percentage is hydrogen? It's not so bad. All you're going to do is calculate the mass of the element specifically, and then the mass of the entire molecule, divide it, and multiply times 100. And we would do this for each one. So CH4 has a mass of 1 carbon, 12.01, plus 4 hydrogens, 1.01. And 12.01 plus 1, 4.04 is going to be 16.05. That's the mass of the entire molecule. So to get the percent composition, we would get, let's see, so for CH4, for the carbon, we would do 12.01 grams divided by 16.05 grams, and we end up, and we multiply it times 100, so, oh, I hit times, hold on, let me try that again, divided by 16.05, and we get 0.748 times 100 to get a percentage, 74.8%. So the carbon is 74.8% of the total makeup. All right, hydrogen. Since there's 4 of them, we're not going to put in 1.01. We're going to put in 4.04, 4 times that. So 4.04 divided by the 16.05. And we're going to divide that out, multiply times 100. I did it again, hold on. And we're getting 0.2517 times 100, 25.17, or let's go 25.2%. So by mass, CH4 is 75% carbon and 25% hydrogen. Make sure that these numbers should total 100% once you're done. And 75 and 25 does equal 100. Now, because of rounding, it might be slightly off, but it should be like 99.9% if it's off by a little bit. All right, let's continue and do another one. We'll do them all, actually. What is the percent composition by mass of H2O? H2O would be 2 hydrogens, 2 times 1.01, plus oxygen, which is 16.00, for a total of 18.02 grams. Let's get this figured out now. Okay, so hydrogen, and there's 2 of them, so 2 times this is 2.02 grams divided by the 18.02 grams. Is 11.2%. 11.2%. Don't forget to multiply times 100 to turn it into a percentage. The oxygen is 16 grams over the 18.02 grams. %. And same thing, you can see that it will add up to 100. So we're good. Water is 11.2% hydrogen and 88.8% oxygen by mass. One more. We'll do with the rest of them. All right, let's see, lithium hydroxide. So lithium has a mass of 6.94, and there's just one of them, plus an oxygen, plus a hydrogen. And what do we get? Let's see. 23.95. grams. Okay, so lithium is 6.94 divided by the total. Don't forget to multiply times 100. 28.97, which we're going to round to 29.0%. Oxygen is 16 grams compared to 23.95 grams. Don't forget the 100. 66.8%. And the hydrogen, 1.01 grams over 23.95 grams. Times 100, 4.2%. Okay, why don't we double check this one since we haven't done that? So, 29% plus 66.8% plus 4.2%, and there it is, 100%. All of the mass is accounted for. One last one, Na2CO3. Na2 is, so this is 2 times 22.99 plus a carbon, 12.01, plus 3 oxygens. 2 times 22.99 plus 12.01 plus 3 times 16, and 105.99. That's the total mass of sodium carbonate. Anyhow, let's divide them out and get the mass of each one. So for Na, it's going to be 2 times 22.99, which will be 45.98 grams divided by the total, 105.99 grams. Anyhow, divide that out. Times 100. And we have 43.4%. Next is carbon, which is 1 carbon, 12.01 divided by the entire mass, 105.99. Multiply times 100, 11.3%. And last but not least, oxygen. Now there are 3 oxygens, so 3 times 16 is going to give us 48 grams divided by the 105.99 grams. And let's see. Times 100, 45.3%. All right, so there we have it. That is our breakdown of sodium carbonate by mass percentage. And once again, these numbers will add up to 100%. Your homework is on positive physics, same unit, except this is the percent composition one.